Okay, for chapter 3, we're going to do something a little bit different. I'm actually going to rely on you to be an active learner today and to actually do a video review versus what we normally do in class. So our normal review will take place this way. So we're going to get started with our chapter 3 review. If you want to follow along, we're looking at page 203 of the book. As we have started this particular chapter has dealt specifically with lines, and we've talked about two different ways to name lines. And the first way is through linear equations by using standard form. So when you have the standard form of an equation, the standard form always comes in the order of x plus y equals your constant. And if you remember, the constant is just your number. So if you have a constant is a number alone. So this is number only. If you are given any other form of a line or everything is in a different pattern, you always want to solve for the number. The whole point is to get the variables on one side and to get the number on the other. So if your equation said 2x plus 3 equals 4y, this would be a linear equation. However, it is not in standard form. So to turn it into standard form, we have to get this guy on one side and the 4y on the other. So we could subtract 3 from both sides, and this would turn into 2x is equal to 4y minus 3. But again, we want to get the constant alone, so we have to move this to the other side. So we're going to have to subtract 4y from both sides, and we will get 2x minus 4y is equal to negative 3. This equation right here is a linear equation in standard form. However, we also learn a second form of an equation. The second form is called slope-intercept form. The slope-intercept form is the easiest one to deal with because everything is already lined out in an equation form like you would put it in your calculator, and it starts with y equals. It's y equals mx plus b, and every one of these four variables means something different. So the y, as you'll remember, is your y coordinate. The m is one of the most important pieces. This is your slope. The x is the x coordinate. And b is also the other important piece, which is your y-intercept. The three pieces, or the two pieces that you have to have into this particular equation are, you have to have your y-intercept and you have to have your slope. Now, if you go back to what we had before, we also have a slope formula. So, equation for slope. When you are given 2 points, let's say for example you have 1, 4 and -2, -3. If these are 2 points and they ask you to find the slope, you have to label which one is x1, y1, x2, and y2. So we're going to name this x1, y1, and x2, y2. Because our formula for slope, which is m equals y2 minus y1 over x2 minus x1 will help us find the slope of the line. So all I'm going to do is take these numbers and plug them in. So I have y2, which is -3, minus y1, which is 4, over -2 minus -1, or minus 1. Now whenever you put these in, use your calculator if you want to. But do your best, especially if you have a double negative down here, to recognize your double negative. But this is -3 minus 4, which gives you -7, over -3. Slope, 90% of the time, is going to come in fraction form. And you want it to be in fraction form because the slope means something really important. If you have slope of, let's say, 1 over 2. This is your rise over your run. So if this is your slope that you're given, and let's say we have a graph and let's say that this is our first point, but you know that the slope is 1 over 2. Then this means rise up one time and over twice. And then rise up one time and over twice. So you could graph this line with 1 point and a slope alone, because the slope tells you the rate at which it increases or the rate at which it decreases. Like we've talked about in class, you have two different kinds of, actually you have 4 different kinds of slope. You could have a 0, an undefined, a positive, and a negative slope. You just have to be really careful as you graph your line to make sure that you know which one you're dealing with. Alright, the next part is we talked about direct variation. Direct variation is when a line passes through 0. If you remember correctly, when you have a direct variation, it will look like y equals 2x. There will be missing a constant because the constant is understood to be 0. So if you have this particular scenario, you could actually graph this 2 different ways. First of all, since there is no constant, you know that the line automatically has 1 point at 0, 0. It goes through the constant. Now, the first thing that you can do to actually graph this is make yourself a chart. Choose values for x. This is the part where you get to choose what you want x to be. Choose values for x and solve for y. So start with 0. We already know this one. If we put 0 in, then y is also 0. Put 1 in for x. So if x is 1, 2 times 1 is 2. So y is 2. Put 2 in for x. 2 times 2 is 4. So now you can go back to your graph and you can graph your second point. So if this is your second point, 1, 2, you can actually graph that on your graph now. So I can go over 1 and up 2, and now I have enough to make a line. Because this slope is positive, I know that this is a constant increase line and not a constant decrease. So as I graph it, the graph should actually be going up in the positive direction. We've also talked a little bit about sequences, arithmetic sequences, like if you have -1, 0, 1, 2, and looking at the rate of change. You're adding 1 each time in this sequence. And we've also discovered that you can have sequences in multiplication facts as well as sequences in your x and y variables. As one changes, the other changes a different way. If you have a direct variation, if it's proportional relationship, as one changes the other, then the graph will actually go through 0, 0. If it is non-proportional, then the graph will not go through 0, 0, meaning if the change is variable based on whatever the equation says. Excuse me. Now, we're going to look at a few ways to graph because graphing is going to be the largest part of your test as well as slope. So let's look at a few examples. Alright, so if you'll get out your graph paper, that would be wonderful. We are going to look at, first of all, y equals -x plus 2. If you were asked to graph this on the test, this is where you get to choose values. So you can do your x and y chart like normal, and you get to choose what you want to put in for x. Because I think it's easiest, I always like to start with 0 and put 0 in for x. So if I put 0 in for x, this becomes y equals 0 plus 2, and y would equal 2. So that means my y value here is 2. Now I'm going to do just the next number up. I'm going to do 1. So that would be y equals -1 plus 2. So then y would equal -1 positive 2. That just gives you 1. So now I have enough to be able to graph the line. All you need are 2 different coordinates. So this coordinate is 0, 2, and this coordinate is 1, 1. So now what does that look like on a graph? So start your graph. You don't have to go real far on this one. 4 on each side or 3 on each side would be fine. So the first one is 0, 2, so over none, up 2. And the next one is 1, 1, over 1, up 1. Now, on this particular graph, just to make sure that I'm correct, The graph itself does go down, meaning it goes in the negative direction towards the end on the right, which means that my slope should be negative. So if I go back to my equation, the number in front of the x, which is a general known as a -1, that number is negative. So I know that I have a constant decline and that my graph should be about correct. So let's look at another. Alright, the next one we're going to look at is 3x plus 1 equals -2. Alright, and this particular one, again, we can do the same thing. This is not actually going to be a normal linear graph that we would have had. And what I want you to think about is why that might be a little different. In any particular line, the line that you give has to have an x, y, and a constant. This particular line does not have a y value. So it's a little bit different than what we've done before. This one is going to be different, and we'll talk about it today. But in this one, what I'm going to do is I'm going to solve for x. So this one, I'm going to take away 1 from both sides, and I get 3x is equal to -3. Now again, I have multiplication, I get rid of it by division. So x is equal to -1. What that means is, no matter what your y value is, every x value has to be -1. So if you get to a point where you only have one letter, and even if it said y equals -1, that would mean every y value has to be -1. So if I do my chart, that means every x has to be -1. It means it does not matter what I put in for y. So I could put in 0 and 1 here. It doesn't matter. Only these two matter. That line is going to look a little bit different than what we've seen before. This particular line is either going to be vertical or horizontal, and you'll see which one. So we're going to go over -1, up none, over -1, up 1. So this is x equals -1. Every x value, -1. So these lines are going to look a little bit different if you have x equals a number or y equals a number. Okay, now this time we're going to do one similar to what you did yesterday in class. We're actually going to look at a line where they give you the points in the graph. You have to find the slope and then turn it back into the equation for a line. So here's our graph. So on these particular problems, they're going to give you a graph. So you're going to have a graph given. Find the equation of the line. Alright, on this particular graph, the way that you go about this again is every equation of a line should start with y equals, and then you have your mx plus b. Now, from what we said before, the values you really want are your slope and your y-intercept. With these values, you can actually write the equation of the line. So the first thing that we're going to do is we have to know the coordinates of this point and the coordinates of this point. So this one is over 3 up 1. So this coordinate is 3, 1. And this coordinate is over -2 down 2. So that's -2 comma -2. With these 2 points, I can now find my slope. If you remember, slope is y2 minus y1 over x2 minus x1. So label your points. x1, y1, x2, y2. Now plug them back in. So I'm going to do -2 minus 1 over -2 minus 3. So -2 minus 1 gives us -3. -2 minus 3 gives us -5. And we also have a double negative, so this is just going to turn out to be 3/5. So here's my slope. My slope is 3/5. Now the question becomes, where does it hit the y-axis? If my graph were a little more perfect, you could probably see that it hits right here at 1. So this equation of a line would be y equals 3/5x plus 1. Don't make it more complicated than it has to be. When you go back to put these in the formula, all you have to do is substitute in the slope and the y-intercept. And most y-intercepts, especially on a test, it's going to be a perfect graph, so you're going to be able to see exactly where it hits that y-intercept. Just make sure you put those numbers back in there. Watch out for the double negatives. If this were to be, let's say, -3 up here, and it's not, but if it were, and I had to do -2 minus a -3, that would have given us a double negative, which would have completely changed our slope in general. So just be really careful to make sure that you input things correctly, that you're showing your work, and on the test, make sure you show as much work as you can. I can give you partial credit if I figure out what it is that you've done wrong along the way. It makes it a whole lot easier for me to be able to figure out whether it was just an arithmetic problem or whether it was just a problem where you completely didn't understand what was going on for the test. Generally speaking, majority of the test is slope, graphing, talking about direct variation. If you know how to do all of those things, you're going to be fine on the test. As you start your review, if there are issues that you need to refine or perfect, go back to the video, consult what you're doing before you get started on your homework. If you have any questions, then always feel free. On Thursday, we're going to go completely through the review. So ask questions as we go through. Make sure you double check your answers. If you know what you're doing on the self-test in the book, it's going to make it a whole lot easier for you to get through on the test. Good luck.